Okay, today we shall be discussing theoretical distributions, and in theoretical distributions there are three types which we are going to discuss in our syllabus. The first one is binomial distribution, the second one is the Poisson distribution, and the third one is normal distributions. These two are discrete probability distributions. These are discrete. Okay, these are discrete, and this one is a continuous probability distribution. Fine. Now in this class we shall be discussing binomial distribution. So what is a binomial distribution? Let us try to understand what is a binomial distribution. Okay, we will be covering one distribution in each video. So let us try to understand how a binomial distribution or what and how a binomial distribution works. Okay, so first of all, this distribution assumes only discrete values. Okay, this distribution, note that this distribution, it assumes only discrete values. Means it can be 1, 2, 3, 4, 5, 6 like that. Okay, full integer values only, not 2.5 or 7.5 and so on. So the value that it can take is this. Okay, binomial distribution, the values that it can take, it can have is discrete values only. Okay, this is one thing, that is your x should be equal to, the random variable x can be 1, 2, 3 up to say any value n. It should be finite. N should be finite. Okay, n should be finite. Okay, why do we use this? That is another thing. And when do we use this? Okay, before going there, we should understand what a Bernoulli trial means. Okay, what is a Bernoulli? This is based on binomial distribution, is based on Bernoulli trial. Bernoulli trials. What do we mean by Bernoulli's trials? What do we mean by Bernoulli's trials? Let us try to understand what Bernoulli trials are. See, we know what a random experiment is, and when we are talking about a random experiment, conducting the experiment once is called a trial of the experiment, right? It is called a trial of the experiment. So therefore, if the trial of the experiment, of a random experiment, okay, they satisfy the following conditions, then we can say that it is called a Bernoulli trial. First condition is that the number of trials should be finite. Okay, number of trials should be finite. Okay, that is, it should be a known number, a fixed natural number. Okay, second property is that the trials should be independent with each other. Okay, the trials should be independent. Okay, the example is that in case if we toss a coin, say 5 times, okay, and will the tossing of the coin in the first trial make any kind of difference in the second trial, or is the second trial dependent upon the first trial in any way? No. So therefore such a trial will be independent. The second trial is totally independent from the first trial. Okay, I'm tossing it once, I get a result. I'm tossing it second, and the second time I get another result or the same result, whatever. Okay, but the first trial in no way influences the second trial. Okay, so that's what we mean here. So now the third condition is that it has exactly two outcomes. It has every trial, the outcome of every trial can be exclusively discussed or distributed as a success or a failure. Every trial has only two outcomes. One of them will be known as the success, and the second one, or and the second one will be known as the failure. Okay, here the probability of success will be denoted by P in each trial, and Q will represent the probability of failure in each trial. Okay, now the fourth condition. What is the fourth condition? Fourth condition says that the probability of success and failure do not change throughout the experiment. For the first time, the probability of getting ahead was something, and in the second trial, it changes. No, it doesn't happen like that. Every trial, it is the same. Okay, the probability of success and failure. The probability of success and failure remains constant. Okay, the probability of success and failure remains constant throughout the experiment. Okay, that's what we mean here. Now, say for example, you toss a coin 10 times. Okay, tossing a coin, say 10 times. What is the probability? What is the probability of getting, say, 5 heads? Okay, what is the probability of getting 5 heads? Okay, in this case, what can we do? See, for each trial, we can have a head or a tail. So the probability of getting success is equal to, say for example, getting a head is success. So here, getting a head is called a success. Okay, what is success? Success means getting a head. Okay, getting a head, not a head, it is getting a head is called a success. Now, we here one trial. Okay, one trial will be like this. It will be either a head or it will be either a tail. Okay, it will be either a head or a tail. Okay, what is the probability of getting a head here? Okay, that is 1 by 2. And what is the probability of getting a tail? That is 1 by 2. So here in this case, this is your P, this is your P, and this is your Q. Okay, this is your Q. This is P is equal to 1 by 2 and Q also equal to 1 by 2. Clearly P plus Q is equal to 1. Okay, for each trial, P plus Q is equal to 1. That is, probability of success plus probability of failure will be equal to the universal probability. They are mutually exclusive and exhaustive events. Okay, now this question, tossing a coin 10 times, what is the probability of getting 5 heads? How can we calculate this thing? This will be actually very difficult because it is 10 times, so the sample space will become very large. So let us look into a formula. Okay, let us understand a formula, and the formula is this: probability of x equal to 5. Okay, probability of x equal to 5, or x equal to probability of x equal to small x or r. We can take it as x equal to x or x equal to r. Okay, and that will be NCR into okay, probability of x equal to r, that is NCR into P. P is small p. Okay, small p raised to r into q raised to n minus r. Okay, NCR into p raised to r into q raised to n minus r. Here we know that p plus q is equal to 1, so q is equal to 1 minus p. Okay, here q will be equal to 1 minus p, and what is r? R is the number of success required. R is the number of success required. N is equal to number of trials, and Everything else is given here. Okay, n is the number of trials. We know all these things. N minus x or n minus r. What is n minus r? N minus r is nothing else but n minus r will be equal to, what is r is the number of success required. R, n minus r is the number of failures. Number of failures. Okay, so we know all these things. We can just put up the values. N minus r is not required actually, because from these two we can clearly define these items. Okay, so this item or this formula is called the binomial function. Okay, this function is called the binomial function, and this can be used to find out the probability of getting 5 heads. Okay, here in this case, now in this case of getting of 5 heads and n is equal to 5. In this case, what do we have here? N is equal to 10 and r is equal to 5. Okay, so our probability function. Okay, so our probability function p of x equal to r, or x equal to r is equal to 5. So I'll take x equal to 5. What it will be? N is equal to 10c5. 10c5. What was p? P was equal to 1 by 2. So I will take 1 by 2 the whole raised to 1 by 2 the whole raised to r, that is equal to 5, into, this is 1 by 2 again q the whole raised to n minus r, that is 10 minus 5 is again 5. Okay, so here what is 10c5? 10c5 is, we know how to calculate 10c5. Okay, so let me calculate that somewhere here. Okay, this is 10c5. How can we do that? This is 10 into 10 into 9 into 7 into, what is happening? 9 into 8 into 7 into 6. So this much we need to write, and then divided by 5 into 4 into 3 into 2 into 1. Okay, so this is 3 into 2 is equal to 6. 4 into 2 is equal to 8. Then 5 2s are 10. Okay, it is 9 7s are 63 into 4. Okay, what is 63 into 4? Let me calculate. So 63 into 4 is equal to 252. So this is equal to 252. Okay, NC5 is equal to 252. So I will be getting 252 into 1 by 2 raised to 5. That is 1 by 2 raised to 10. 5 plus 5 is 10. Okay, by 2 raised to 10. What is 2 raised to 10? 1024. Okay, 2 raised to 10 is equal to 1024. This is 252 divided by 1024. Okay, that is 252 divided by 1024 is equal to 0.24. Okay, that is equal to 0.246 and so on. Okay, this is your probability. So this function is called the binomial function. Okay, so now we should understand what is a binomial distribution. Okay, now this is binomial distribution. Okay, in binomial distribution, the probability mass function, or the probability mass function. Okay, what is this? This is probability mass function. Okay, this is the probability mass function f of x. Okay, f of x is given by ncx. Instead of r, we take as x into, this is p raised to x into q raised to n minus x. Okay, here the condition is that n is finite and n is equal to, say, 1, 2, 3, up to like that. Okay, up to a fixed value n. This should be finite. Okay, n will be a finite value. That is what we mean here, and we know all the remaining as discussed in the previous case. Okay, this is the probability mass function for binomial distribution. Okay, now some properties. Okay, we shall discuss some properties of binomial distribution. Some properties of binomial distribution. The first one is that we know that sum of all, or the total probability, will always be 1. Okay, so the first property says that n, so we know that n is greater than 0. Here n is greater than 0, right? Since n is greater than 0, probability of success will lie between 0 and 1. Very clear. Same way, the probability of failure will also lie between 0 and 1. Correct? So because of these things, this is positive, this is positive, and this is already positive. So therefore, this implies also that n is positive. N is positive. Also, n is greater than 0. N is greater than 0. All these three things implies that the function f of x is positive. Therefore, the probability function f of x is positive for all x, or non-negative for all x, and sum of sigma f of x. Okay, sigma f of x equal to x. Sigma f of x equal to x, or we can write it as sigma f of x equal to x. Sum of all probabilities will be equal to 1. Okay, total probability. This means total probability A is 1. This means that probability is always greater than or equal to 0, or non-negative. Probability is a non-negative value. This is the meaning here, and for this notation, it means that the total probability is 1. Okay, this is what we need to understand. The second property is that the mean. Okay, second property says that the mean. Okay, mean of a binomial distribution. Mean of a binomial distribution is defined as n into p. Okay, p is the probability of success, n is the number of trials. Mean of binomial distribution is defined as np. The third property says that the variance. Okay, this is variance. Variance is equal to np into q. N into p into q. Okay, so this implies that's what is standard deviation. Standard deviation. What is standard deviation? It is equal to square root of n, p and q. Okay, product of n, p, q. Okay. Also we should understand that. One main property, very important relationship between the mean and variance. Okay, mean of a note. Okay, we shall write this as note. Note this. Note that the variance of a binomial distribution is always less than its mean. The variance is always less than its mean. Okay, the variance is less than mean. Variance is less than mean. We should understand that. And the variance attains its maximum value. Okay, variance is maximum when if p is equal to q. Okay, and obviously it will be equal to 1 by 2, because when both of them are equal, it will be equal to 1 minus 1 by 2 is 1 by 2. So therefore, when p and q are equal to 1 by 2, the variance will be maximum, and the max variance will be. So therefore, the maximum variance. Okay, maximum variance will be equal to n by 4. Okay, this is a very important point. Maximum variance will be n by 4. Okay, now let us move on to the next property. Okay, the binomial distribution. Okay, this is the binomial distribution. Okay, there are what is the mode of a binomial distribution? Okay, mode. We shall now discuss. We have discussed the mean. We have discussed the median. We have discussed the mean. We have discussed the variance, standard deviation. Now we shall discuss mode of a binomial distribution. mode of a binomial distribution depends upon the value of n plus 1 into p. Okay, it depends, mode depends on, okay, depends on value of n plus 1 by p. Okay, mode depends on the value of n plus 1 into p. Okay, so now the first case we shall discuss the different cases. The first case, that in case if the grade n plus 1 into p is a non-integer, if n plus 1 into p is not an integer, okay, not an integer, okay, we know what is an integer. If n plus 1 into p is not an integer, then the mode of then what happens? Then mode of the binomial distribution will be equal to the greatest, okay, greatest integer contained in n plus 1 into p. Okay, so for example, if n plus 1 into p is say 7.3, so then the greatest integer contained in n plus 1 into p will be 7. Okay, we discard the decimal point. That is what we do here. Okay, you can understand that. Now the second point, that is, if n plus 1 is an integer, if n plus 1 into p is an integer, okay, there are only two possibilities: if it is either an integer or a non-integer. If it is not an integer, then the mode is equal to the greatest integer contained in this thing, and it will become unimodal. This is unimodal, one mode. Okay, now if n plus 1 into p is an integer, okay, if it is an integer, then what? If it is an integer, then there are two modes. Then the binomial distribution is bimodal. Then the binomial distribution is bimodal. Okay, bimodal, and the modes are n plus 1 into p and its previous integer, that is n plus 1 into p minus 1. Okay, this is like this. Okay, n plus 1 into p minus 1. You subtract 1 from this integer, what you get is the previous number. So both those numbers are, say for example, if n plus 1 into p is say 7, then 7 and 6 are both the modes of the binomial distribution. Okay, that is what we mean here. Let me go further. Now, say for example, it is denoted by, okay, it has two parameters: the binomial distribution, the characteristics. Okay, the binomial distribution has two characteristics. Okay, which are this? It is n and p. N is the number of trials and p is the probability of success. So therefore it is denoted by b, binomial bnp. Okay, bnp. This is how it is denoted. Okay, bnp. This is the notation of binomial distribution with parameters n and p. Okay, binomial distribution with n and p, with parameters n and p. Okay, so that's it. Now say consider the next one. Okay, we discussed the mode. Now the next property is that if suppose say x and y are independent, okay, are independent variables, okay, such that say x, what is x? X has the binomial distribution b n1 in comma p, and y has the binomial distribution b n2 comma p. Okay, both have the same probabilities. but the number of trials are different. Both have the same probabilities. Then we can have x plus y. Okay, we can add the two independent variables, and then what you get is the binomial distribution. Their corresponding binomial distribution will also be equal to, this is n1 plus n2 comma p. Okay, this is what we should know. Okay, this is same, this is same, and this is same. Okay, so these are the theoretical aspects for binomial distribution. Now we shall consider one or two problems. Okay,